Third thing, fine. Let's start with the class called file. Okay. Fine. So object of a file is used for representing a abstract path. It represents object of file, right? Okay. So what do we mean by this abstract path? What is a path like? Okay. So a path here, when we say path, a file object here. So okay, we may even start by looking at first the constructors. Let's see the constructors here. Okay. You can create a file object with the help of a string, and which is nothing but your path. Okay. So what can this string be like? The format of the path. What's the format for the path? Right? So it would have a prefix part which is optional. Okay. Optional prefix. Okay. So it has an optional prefix followed by multiple names. Okay. There are multiple names separated by what we call as a separator. Fine. Separator, fine. This separator depends on the file's operating system. Okay. Okay. Separator, for example, we have, in case of Linux, we would use slash. Fine. For Windows, it may be backslash. Okay. Fine. As such, I shouldn't put the double quotes around, because if that's double quote for a backslash, I need to backslash. Okay. But I'm just, anyway, it's a text and not a Java string. Don't look at it as a Java string. Okay. And this is not the Java string. Okay, let me put that's better. Okay. Then a separator would be slash or backslash. Okay, so a file class, yeah. Fine. So it's nothing but optional prefix. So what? Yeah, what is that prefix? Why we are saying optional prefix? Separator and names. Yeah, we understand that, right? That's where we are giving the hierarchy. Okay, fine. So now one more thing here I must say. Okay, except for the last name. Okay, it's a series of names, right? It's a list of multiple names. So fine. Except for the last name. Okay, names will be a directory. The name of a directory. They represent name of a directory. Okay. Last name can be for a directory or a file. Okay. Anyway, a directory is also considered as a file, but I want to make a distinction here, right? Okay. So this is what is there, but yeah, we still are missing what is the prefix. What is that optional prefix? Okay, some example for the names and how they may be separated. For example, someone might say, okay, so let's say it's a Windows system, right? So if it's a Windows system, You might have say, we have got Java 2204 backslash src. Yeah, there are two names separated by a separator. This is the separator we are using, right? And there are two names in this. And you can see, oh, this one is a directory. Oh, last one here, oh, this is also a directory. It's fine. Okay, so this is one example of that series of paths separated by a separator. So the separator is here, right? So this is one example. Another example which we may do is we can say, okay, src backslash test. Again, a directory. Okay, so this entire thing is a directory, where the last one is a directory, and here someone says, okay, we have the testbag.java. Here the last name is this is the last name. The last name here is for a file. In earlier cases, they have all been the directory names. Okay. Okay. So what's a prefix? What could the prefix be? Yeah. Yeah. Drive. So okay. So prefix could be something like this. Okay. So just the prefix part, I mean, C colon backslash user backslash. Yeah, that's what it is on this local machine, right? And then again a backslash. So that's my prefix. Okay, this is the prefix. On Linux, your prefix would be slash. When slash, that's a prefix. Okay. Fine. So you could see examples of here. The idea is this is a prefix part. Okay. Optional. Yeah. This is also valid for me. I don't have a prefix, or I have this. Okay. Fine. So this is the prefix, and following that is this one, right? Okay. Prefix plus this.
But to locate any
Yeah.
file or directory,
Yeah.
the program is an absolute path.
Okay. Now, when you create a file object, how do you create? You may create with this also, right? You can use this also to create a file object. Okay. It's a relative path. Okay. It's a relative path. Path is either absolute or relative. When you have the prefix, it's an absolute path. Without the prefix, it's a relative path.
Other system, the home drive will be different.
Yeah, yeah. It may be different. So whatever the so this is so that you are this is in case you are planning to give a absolute path. Just an example of the prefix. Right? So it's a list of names separated by a separator. Okay, fine. Now a few things here. So yes, we started with the constructor, but even before constructor, let me also talk about some public. So in the file class, yeah, there are a few things here. Okay, public static final. Okay, type would be string. Name of the variable is separator. Okay, so we have this declaration in the file class. Okay, equal to, and what will it be? It depends on your operating system. If your OS is Windows, it would be a backslash. If your OS is, so on Windows, it would have been like this. Okay, on Linux, this would be, so there is a variable called separator. So you can just say file.separator, and you can know whether it is Windows or Linux like that.
One line, one slash is
No, this is our Java string. To write a backslash, you actually need two backslashes when you're putting within double quotes. Okay. This is not a valid thing in Java. Okay. When you say double quotes, any occurrence of a backslash would be interpreted. Oh, what is it? It is it alone. A backslash alone is not valid. It's not one character. Okay, that's not a valid string. If I say backslash s or backslash t, sorry, yeah, backslash t. So backslash is used as escaping character in a string. Okay, so when we so a single backslash is never valid. It will always be interpreted by taking the help of the following character. Oh, what does it mean? Oh, it is a t, and therefore it represents a tab. If I say backslash backslash, then it represents one backslash. Okay. Two backslash. URL. Yeah, URL has a different thing because that's the rule of the URL. You're talking about this system. Here we have back to where are the slash slash? This one, right? So that's rule for the URL. Here we are not talking about URL. Okay. Purpose. No, this separator refers to the separator used for separating the names in a path on a file system.
Whereas URL is on a URI space basically. It's in the hyperspace.
Okay, so we have this two things are like this. Okay, there are two more. So not this is only one. Okay, it's only this is what is for, or rather I should say Unix, and this is for
But it's final.
yeah, it is fine.
So, so that means for the Windows, the JRE will be in the JRE.
Yeah, the class file is different. Okay. Basically, there are other means also. So someone can use this to find out what is the operating system. Is it like Unix like or is it Windows like? Okay. So that can be file dot separator that can be used, but there are actually other better ways of doing it. Okay. System JVM has properties which you can ask for. And so you can ask for even what is the Java version which I'm currently working on. Okay, you can know that also. Okay, fine. So one is a one field name is separator. There's another field name also, public static. Again, different for both of them. Type string, and it's called path separator. And that's equal to, for Windows, it would be a semicolon, and for Linux, it would be a colon. That's a one field. And depending on your system, the value will be different. Okay, what you get will be different. Okay, and exactly like this, but you don't want it as a string type, but you want it as a char type. same two fields available even in char type. So it will be called separator char equal to, it's in char type. It becomes a char type. That's it. So both the things are like this available. Okay. So I think you will understand this now. And I don't want to put the same thing again, but the type is char. As a char type, so these are the four fields we have. Okay. And public static final, type string, separator and path separator, type char, separator char and path separator char. Okay. Okay. The values will depend on your OS. Fine. Now coming to this, so what is a file object? Okay. Call it, okay. Let me continue with the constructors again. So one constructor we had seen earlier. Okay. And we yeah. Okay. So this is one. Okay. Another constructor says, okay, you can give it me in two parts. Okay. That is, you give a path to a directory and another string for the name within that. Okay. Or you could create a file object by using a file object which is for a directory and a string for the name. There is a file object which represents a path. Fine, the path is to a directory or to a file. If there is a path to a directory, and if I have such a file object, yes, I can use it to create another file object relative to that particular. Right? So if your paths are relative path which you are using, okay, then they will be relative to what? Which directory? The directory from where you are running the application. Okay. When you run your application, maybe, oh, you are running from SRC folder, oh, they are relative to SRC. And clear? Okay, so constructors like this. Okay, let's look at a method now. See, first thing, okay, you created a file object. What is it? It's just an abstract path. There's nothing. Fine, it's not exactly that, oh, we have a physical file. That's not necessary. Right? You have this public method. So now these are methods. Okay, so we have a public method returns a Boolean value. Okay, we can check for access. Okay, so you could just say, okay, let me create a file as, so someone says, okay, let me have a file. Okay, new equal to, and you could be saying, okay, let's say, oh, this is for your Linux system, abc/xyz. So if you have written like this, yes. Do we have this folder called ABC? No, we don't have. Even XYZ, it's not there. Right? But this is a valid file object. Okay, this is a valid file object. Okay, now you can check whether new directory dot exists, and that should be returning a true or false. It doesn't exist. Okay, fine. If it exists, yes, it will say fine. This can exist, right? ABC/XYZ. If it doesn't exist, yeah, clear? Okay. Now, if it doesn't exist, what do you want to do? Would you like to create a file? Or would you like to get the create a directory by this? Do you want to create a folder like this? So someone could, so okay, now the next method, right? So we have another public method returns Boolean. Okay, method name is mkdir. Okay, there's also a method called mkdirs. Okay. What are these going to do? If it doesn't exist, you can create. With mkdir, suppose I used it with this new directory, right? If someone says, oh, that would fail. In case ABC doesn't exist. ABC exists, XYZ is not there, then this would be successful. Okay, clear? Right. So if I say mkdir, only the last path, last name, before that everything, if it is existing, then it can create the directory. Okay. Whereas in this case, even if previous things are not existing, it can still create all the path. The entire path can be created. Okay. Fine. So you might be able to use mkdirs also, and returns Boolean. Right? Fine. So one method we saw was exists. Okay. Other method to create a directory. Okay. Fine. Or maybe you're not interested in creating a directory, but you're interested in creating a file, not the directory, but a file. Okay. So we even have, so I'll add the method here, create new file. Path is already there. You don't have to pass any parameter here. Fine. When you created the object, you have the path. Okay. So what it has to create is known. Fine. So this is for creating file, these two for creating directory. A zero size file will be created. That's it. 0 byte file. Okay, just to create a file. Okay, just like we check for exists, we have the method to return Boolean. Okay, and is this path representing a physical directory? First, exists must be true before. So if exists is false, this is definitely false. Okay, same way we even can say is 5. Is it a directory or is it a file? You can check that also anytime. Okay, but create the path for that first. Create the file object, and then you can check like this. Is directory, is file, right? See, on Linux file system, you can see read, write, execute permissions are there, right? Then for every file or directory, there is a read, write, execute permission. So do we have the read or the write or the execute permission? So even for that, can read. You can check like this. So can read, can write, can execute. method returns boolean, right? Whether we can read, write, or execute. For Windows system, we can even do one more thing, is read only. Oh, there is a read only attribute which may have been set. It has basically attributes like this, right? We even have something like, so these are nothing but for a given path, you are checking various kinds of attributes. Create a file object, that's a path. And then what all we can know about that path. Right? It physically exists or not is the first thing you will have to check. Right? If it's physically there, then so many other information about that. Okay. Okay. Is hidden. No, oh, you want to set the attribute? Yeah, yeah. So yes, you can. So that I think return type will have to be checked. Yes, it's void mainly. So set read only. Pass a boolean. Read only attribute can be set to true or false. Okay, so it can be made read only, it can be made hidden. Okay, for Linux, you would like to set read readable. I think it is set readable. Okay, pass a boolean. Okay, fine. For read attribute, so you can set. Okay, there are this is setter method here is overloaded, so you can pass boolean as well as, okay, another, I think this is boolean, yeah, another boolean. Okay, to set it only for the owner. And there is owner, right? In Linux we have 3 levels, right? Owner, group, or the world, right? For everyone. There are 3 sets of permissions: read, write, execute. Read, write, execute for the owner or the self, we say, right? Other is for the group, and the third attribute is for the all, right? Rest of them, we call it as the world, right? So set readable, set writable, set executable. Okay, fine. Yes, similar such methods are there. Fine. So these are all about checking the things. Okay, permissions and things. Okay, you can even now taking more actions like, oh, these are settings. So these are the action, right? Actionable things. We even have some more actionable things. Okay. Okay. Even before this, one more method which I can. These are some static methods which we have. Okay, so we have the public and static method, especially useful for Windows environment. Okay, so we have a static method to return a file array of file. Okay, method name is list roots. On Linux this would have only one entry, that's a slash, whereas on Windows whatever drives are available, fine, so it will say C colon backslash D colon backslash, and whichever drives are there. So many, and that would be the size of the array. So for each available drive, yes, you will have the object for the root directory of each of the drives. Okay, there are other methods as well. Okay, some more, some getter methods. Okay, example, returns long, get available space. Okay. get total space, and method like get usable space. Okay. So this would be for whatever your file object may be, it would be on some particular drive. So for that drive, this is giving that information. And for the drive of the current path, whatever your path is. Okay, it is for a particular drive. So for that drive, yes, it will give you all this information. Okay, in terms of number of bytes. Okay, some actionable things like we were setting, right? So let me put some actionable things. Okay, a method to return boolean, and method name is delete. If it's a directory, it would require that it should be empty, right? Okay. We know this. Only empty directories can be deleted. Okay. So this is used for deleting file or a directory both. Okay. We even have other method like this, returns boolean, and name of the method will be rename to. And when we say rename to, you'll have to pass another path. Okay. So parameter is the path. Okay. So it's like f1 dot rename to f2. So f2 is also a file object, f1 is also a file object. So on f1, if you are calling this method, and it so happens that f1 must be existing and f2 must not be existing. Okay. After this is successful, it will be the other way around. f2 will exist, f1 will not exist. Okay. So if this is successful,
It will work in
it
the
will.
same directory.
No, not necessarily. It can do the moving of files.
So it will do the moving also.
Fine. So delete, rename, yeah. Create directory, that we have seen. And removing directory is no separate thing. Delete is going to do that job. Yeah. Okay. There are methods like this. Public method to return get parent. Get parent. I think it's get parent or get parent directory. I'm not sure of the name. I think it is called get parent. Yeah. And that should be returning a string. Whereas there's another method called get parent file, which will be returning it as a file object. As a file object. Okay. Yeah. So except for the last name, the previous name, up to the file, just discards the last name and gives it to you. And we can even check, how the object of path has been created, that file has been created. So you may have created a file. So it has a method like this. How was it created? Did you specify the absolute path? Okay. Or is it a relative path? You can check if it's an absolute or relative. Okay. Other information, yes, about the path. So many things, right? Okay. Uh, okay. Returns a string. Method name will be get name. Gives you the last name. Whatever is the last name in that sequence of names. And so get name gives you the last part. And get parent was giving us the whatever is other than the last name. Okay. We have also method called public method returns string get absolute path. Right? Get the absolute. So whatever you might have created as relative, but then also you can get the full absolute path. Okay. Oh, you want to know the size of the file? Returns long. Method name is length. And the file size. Okay. Fine. We can even find out. So we have a method to return long. Last modified. Last modification date and time. See, date time in Java earlier prior to the Java 8 has always been represented as a millisecond value. So this is that millisecond value. When I use the method called get last modified, find last modified. Last modified gives me the last modification date and time. Okay. Yeah. Okay. Now a few methods which are related to the directory. If it's a direct, if the path is representing a directory, then I can use a method to get a string array. Okay, method called list. If it's a directory, give me the list of all the file names. Okay, fine. This method is overloaded. You can pass as parameter an object of file name filter. I was talking about some kind of a predicate test. Okay, fine. See, example. Let me. Okay. Now for that, here we will need to know what is the file name filter. Okay, but before going to what is file name filter, let me use the other, give the names of other methods, related methods, similar methods. So these is, what is it returning in the string array? Names of the entries in that directory, right? File name or directory name, whatever it may be. Okay. We even have a method to return a file array. Instead of returning as a string array, you can get the file objects itself. Name of the method will be list files. Okay. When you say list files, even this is overloaded. So you might use a file name filter here. Okay. Or you might use file filter object. There are two kinds of predicates. One is a file name filter, other is a file filter. Okay, so let's see the difference between the two of them. Okay, and one more thing, what would you prefer, list or list files? List files, because it's giving me a file object. Once I have a file object, I have more information available. That one is carrying only the name, whereas with a file object I can get what was the last modified and so many attributes about that and about that entry. If someone wants to print just the file names, that may be okay. Okay, but I'm interested in all the attributes of a file, right? Okay, so most find out of the two, list and list files is what is preferred. Okay, same way this one, right? File name filter and file filter. It is the file filter which will be more preferred one. Let's see what the two things are, and then why the preference would be for file filter. Okay, so if I look at a file name filter, okay, fine. So file name filter is nothing but it's a public method returns boolean. Okay, because I already mentioned it's a predicate. Okay, name of the method is not like the method for a predicate. Okay, the method name here is accept, and so it's just whether it is acceptable or not, right? And it takes two parameters. This is for a path to a directory, and another is a string, the name part. So it's extracting the name, separating it out from the parent. Okay, so a parent and a name, two things are here. Okay, so yeah, that's a file name filter. And what is a file filter? Okay, in case of a file filter, only one parameter, the path to the file. Okay. Right. And I'll tell you, this is what would be more preferable compared to this one. Okay, I'll take a small example for this. Okay, for a file name filter, first we'll take an example using. Okay, so I want to list all the Java files in my directory. Okay, I want to list all the Java files in a directory, right? So how will I do that? So I have an object of a file which represents my directory. Okay, equal to, and let's not worry, right? So you created a directory, and in this directory you want to get a list of file objects. So let's use the list files method here. Okay, so I'll say string, not string, file Java files equal to, yeah, list files as a parameter. Okay, we can use lambda expression here. These are function interfaces, one method each. Okay, one abstract method. Yeah. So here, what's the input in the first case? Oh, I have two inputs, a directory and a name. Let me say f name, file name. Okay, yeah. And what will you return? Okay, right? It's end with Java, right? And so that's how you should be doing. Right? If it ends with .java, that's what I want. Oh, that's based on the file name. Okay, now change the exercise and say, okay, I'm not interested in the Java files, but I want those files which are smaller than 1K. Okay, so let me have the small files, smaller than 1K. Yeah. Okay. I can take this part below. Okay. Yeah. What should go here? Small files. Files whose size is less than 1K. What would you do? Okay. Let me show the code here. So given a directory and a file name within that directory, it's a parent child basically. Okay. What would I be doing? I'll first be creating a file object equals new file from the directory and the file name. Okay. And then I'll say return. Right. Okay. Clear? Fine. So we have this fine. How we use it is something like this, right? Okay. Now let me show you how it would work with a file filter. This thing. See, in the first case, there was the file name. Our dependence was only on the file name, so it was so simple for us when we use the file name filter. Here, using file name filter, we have to actually create the file by combining the two things. And then only we can test something about that file. Okay. And most of the time, it would be, okay, I want a list of files within 2 dates. Okay. But then it's about that file, not about the parent and the name. It's giving me the parent and name. Whereas if I'm using a file filter, okay, I would be only having a one parameter. So I even don't need this one. I'll just say, okay. And oh, I won't need this then, right? Yeah. Yeah. Okay. Clear? Why it's more preferable to use a file filter compared to file name filter? See, even if it was something which was based on the name, that earlier thing, I can always use file.getName.len dot ends with. Okay. So if I wanted to do the Java files, okay, this thing. So this is with the file filter, and okay, these two are examples of using the file filter. Java files equal to list files. Or there's only one attribute to me. Sorry. Okay, and that file. Okay, just one invocation, right? Yeah. Okay. Fine. So clear. Okay. So like this, yes, there are lot many other methods in the file class. So, but they all deal with the files basically. Existing file, it exists on a file on a file system. Okay. Only one more thing here. Reference can now from Java 7. Okay. We have what we call as NIO2. Right? When it says NIO2, right? NIO2 refers to java.nio.file package. Okay. So Java 7 introduced the java.nio.file package, and that's what is referred as the NIO2. NIO was introduced in Java 1.4. Okay, and this is from Java 7, NIO.file was there. Okay, so NIO.file, and now why I'm referring here is like file class which is in the java.io package. We have a class called, there is an interface rather, not a file. We have the interface called path. Okay, path. Exactly what we saw about a file class. So we have a interface called path, has much more functions compared to what we can do with a file object. Okay. So java.nio.file, that's a package and it has much more functionality. Okay, and you will find a lot of methods also in a class called file. So in this package there is a class called path, there's also a class called paths. There's a class called files also. Okay, we don't have an interface called file, but there is a class called files. Okay, these would have methods, much more convenient methods. And so what we have seen is in the java.io package, the class called file. But these can also, these will also be all related and useful for a files on a file system. Okay, fine. So we'll continue tomorrow. Fine. So you can refer to these things in the API.
Java original is java.io. That is the original language.
Yes, right from 1.0. Even there also, let me explain. We saw two categories, right? Input stream, output stream, reader writer. Reader writer were for the text, they came in 1.1. Reader writer came in 1.1. So otherwise it was input stream and output stream only in the beginning. Reader writer from 1.1.
Then they introduced this new IO in
1.4. Yeah.
So that new IO is java.nio package.
NIO package. There are so many sub packages there already. Okay, java.nio.careset, java.nio. We have channels, right? Basically, instead of using input stream, output stream, you can use channel basically. Okay, instead of using input stream, output stream. That's a different way basically. There's a different approach. It's based on buffer. Java.nio, the base class there is a class called buffer. Okay, there's a byte buffer. Okay, it's an interface. Buffer is, we have the byte buffer, the char buffer for all the primitive text except for the boolean.
Working with the buffer.
It's, yes, it's a buffered input output. Reading and writing through buffer only, not without the buffer. Buffer is, yes, temporary in memory, like it's an in memory thing. String buffer would also be there, but okay, there's a string buffer input string. That's, so I can be confused with that, but buffer is a concept where it's in memory. Yes, you have a, so when it says buffer of a primitive type, continuous set of values of that type. Instead of array, you can think like that. It's more like the array thing. So like I have a byte array or I have a byte buffer.
It's keeping in memory.
So
the idea is it's keeping in memory.
Yes.
It's not hitting the IO subsystem.
No.
Because the moment you hit the IO
You have
subsystem,
you do have something which can hit the IO subsystem. There's a mapped buffer. Unless it is mapped, yes, it won't hit the IO file system. File system won't be hit. Yes. But there is a concept of mapped buffer of
Putting the IO subsystem means there is a context.
Yes.
So that's time taking.
Fine. Okay. Anyway, so we continue.